The most plentiful element on Earth is oxygen, then it's followed by silicon, which is sand, and the third, quite surprisingly, is aluminium. The existence of aluminium was discovered in England in 1808, and the first bar of it was made for the Paris exhibition in 1885, and Napoleon III took an interest in it for military reasons because he could see it was a light and strong metal, and luckily for the rest of Europe, it wasn't used because the cost of production at that stage made it more precious than gold. We're going to look at very, very quickly the four main areas concerning aluminium as bus bars, and the first of those is connections, then it's short circuit performance, the current carrying capacity, and the cost compared to copper. All connections, metal connections, have to be made through puncturing the oxides. And on aluminium that has to be removed because it's tenacious and brittle and it's unseen, and it has to be taken off in order for the connection to give a decent lifetime. The best way of handling this is plating, and there's four ways in which it can be plated. That's tin, silver, copper and nickel, and we believe that nickel sulfonate is the most effective to do that. You'll find all this information in our much larger part there. The next thing is short circuit performance, and we're going to show 4 videos in a moment, and these will speak for themselves. There's 2 rigs which are identical, making out of aluminium, copper, everything the same, and another 2 rigs, this time with a trefoil arrangement which introduces in electromagnetic forces a vertical impact on it. So you'll see the difference at 50 kA for 1 second between copper and aluminium that are identical to each other. So when the gentleman down the end there are ready, we'll give it a bit of a zap. It's aluminium. You can see it moving around as bars move around in a short circuit situation. Then you see copper. We think that failed the test. Both identical. This is aluminium in the trefoil arrangement. Copper. That also failed the test. People say to us, if we hypothetically change from copper to aluminium, what does it do to our type acidification? And we can say, on the basis of this, our research and our calculations, that in fact it's kinder because it absorbs the energy within itself and it poses less stress on the bus bar system. The other thing I want to mention briefly is current carrying capacity. Aluminium is limited to 90 degrees generally rather than 105 degrees, and for that reason, and for the fact it's not as conductive, it has to be approximately 60% bigger in order to carry the current. And so that can sometimes be a problem to switchboard manufacturers, so we have come up with some rather strange shapes that condenses the bar down, thickens the side in a way that enables us to use the same bus bar support system, still the same connection systems, and condense the whole thing down. The last thing I want to mention is cost. This is not a sales talk, but I can tell you that aluminium is more conductive than copper per weight. It's 1.85 times the conductivity, and of course it's much, much cheaper than copper. So there are great savings, I believe, to be made in aluminium. The last thing I want to finish with, and I was able to speak this morning straight after someone very opportunely spoke about the powder coating on bus bar chassis systems. And I was able to point out that the samples there, if you're interested, of our aluminium is also, most of them, coated with a new type of powder coating which is bendable and peelable, which means the bars are supplied with the insulation on first rather than last. It can be bent and peeled, and this stuff is rated at 5,250 volts in accordance with clause 8222 of 3439.1. So there we are. Thank you very much.